Let's take a look at this full wave center tap rectifier. First, I'm going to convert primary voltage, which is RMS, to peak. Remember, the formula for RMS voltage says VRMS is equal voltage peak times 0.707. I have to find voltage peak. In order to find voltage peak, I have to divide both sides equation by 0.707. 0.7 and 0.7 will cancel out, and I'm going to have voltage peak is equal VRMS over 0.707. I'm looking for the primary voltage peak. That's why I'm going to write over here 1. This is primary, and V1 RMS has to be divided by 0.707 in order to find the primary voltage peak. We have 120 volts divided by 0.707, which is equal 169.73 volts. This is my primary peak voltage. Next, I have to find the secondary voltage, right, which is going to be the value between these 2 points, these 2 terminals. I have to use the formula for transformer, which says V2 over V1 is equal N2 over N1. I'm looking for V2. In order to find V2, I have to solve the proportion by using cross multiplication. And I'm going to have V2 times N1 equals V1 N2. In order to find V2, I have to divide both sides equation by whatever is multiplied to V2. In this case, I have to divide both sides equation by N1. N1 and N1 will cancel out. V2 equals V1 N2 over N1. I have to find voltage secondary peak. So V2 peak is equal V1 peak times N2 over N1, where V1 peak is 169.73 volts. I have to plug this into my formula, which is equal 169.73 volts times N2. This is my N2, and this is my N1. N2 is equal 1 over N1, which is equal 7. Divide 169.73 by 7, and you will have 24.24 volts. This is my secondary voltage across these 2 terminals. Next, we're supposed to find VL peak. You have to remember the formula for the center tap full wave rectifier, which says VL peak is equal V secondary peak over 2 minus VD. Someone is going to ask why I have to divide V secondary by 2. This voltage has to be divided by 2 because I have center tap. How come? Please notice that if I'm going to measure the voltage between this terminal and my center tap, I'm going to have, for example, at this moment, positive half a cycle. If I'm going to measure the voltage at the same moment, when I'm measuring this voltage between this point and this one, I'm going to have something like this. Remember, anytime I have positive half a cycle over here, negative is going to be here. So, when positive half a cycle is going through the diode, I mean through the anode, this diode is going to be forward biased. At the same moment, this diode is going to receive negative half a cycle. Means this diode is going to be reversed biased. So current is going to go like this. At this moment, remember? Anytime there is no physical connection between these two grounds, there is always physical connection. Remember, anytime we have these two symbols, it means that there is physical connection between these 2 points. That's why my current is going to go like this. If I'm going to have negative half a cycle at the top, I'm going to have positive at the bottom. So this positive half a cycle is going to forward bias this diode. So my current this time is going to go like this. So as you can see, at each half a cycle, we're going to use just half of the secondary winding. That's why I have to divide the secondary voltage by 2. V2 peak, which is equal to 24.24 volts over 2 minus VD, which is equal 0.7. This is going to be equal, VL peak is equal 11.42 volts. This is my voltage peak across resistor RL. Next, I'm supposed to find VL average, other words, VLDC. VL average is equal VLDC. The formula for it is VL peak times 0.637. VL average is equal 7.27 volts. This is my DC voltage across resistor RL. Next, we're supposed to find IL peak. IL peak is the current which goes through resistor RL. IL peak I'm going to find by using Ohm's law. Ohm's law says current is equal voltage over resistance. In this case, I have to divide VL peak over RL, where VL peak is equal 11.42 volts divided by RL, which is equal 3.3 kiloohms. IL peak is equal 3.46 milliamps. This is the current peak which goes through this resistor. IL average, I'm going to find by using Ohm's law again. I'm going to simply divide VL average by RL, which is 3.3 kilo in this case. VL average is equal 7.27 volts over RL, which is equal 3.3 kiloohms. This is equal IL average is equal 2.2 milliamps. This is my average current, which is also called DC current. Next, I'm supposed to find PIV. PIV, peak inverse voltage, for this circuit is equal V secondary peak minus VD, where V secondary peak is equal 24.24 volts minus 0.7 volts. So my PIV is equal 23.54 volts. This is my PIV. Next, I'm supposed to find F out. The formula says F out is equal 2 times F in, which is equal 2 times 60 Hertz is equal 120 Hertz. Someone is going to ask, how come I'm going to have 120 Hertz? Please notice that if you are going to look at the oscilloscope and you are going to look at the secondary voltage and output voltage, you will have waves which are going to look like this, like this graph. This is my secondary voltage, which is equal to 24.24, of course, volts. This is the time in seconds. This is the period, 1 full cycle. Voltage across resistor RL is going to look like this. And is going to have the amplitude 11.42 volts. Now you're supposed to look at the periods of these two waves. This is the period of my secondary voltage, and this is the period of my output voltage. As you can see, the period of the secondary voltage is twice longer than the period of the output voltage. So it means the frequency of your output voltage twice of the secondary voltage. That's why I got 120 Hertz. And these are the solutions to this problem.